Okay, what I want to look at is our chemical formula and reaction exam that we just took. And we're going to spend some time going over each question today, just so you understand maybe where you went wrong on some problems. And if you have any questions, feel free to shoot me a comment on this page, and I'll be happy to reply back to you, or I will be happy to visit with you in class if you'll come to tutoring and talk to me. So today, the first question we're going to look at is table salt is sodium chloride and has a chemical formula NaCl. What is the ratio of sodium atoms to chlorine atoms? This really goes back to just some basic math. So we have NaCl. So how many NAs do we have? 1. How many Cl's do we have? Is 1. So it's a 1-to-1 ratio. Okay, which of the following diagrams illustrates a compound? We have to know what the definition is for a compound. A compound is any molecule that is made up of more than one type of atom. So if we look at our pictures, this one is made up entirely of carbon atoms, so that is not the right answer. This one right here for letter H just shows an atom by itself, and then letter J really doesn't let us know what this is, so we can't use that either. This one, however, is 2 hydrogen atoms attached to an oxygen atom. So that is H2O. That is a compound, so our answer is F. Okay, our next question, number 3. In a chemical reaction, it is the action of the blank that are responsible for the changes taking place. So what is it that's causing our changes to take place in these different atoms? Well, we got to look specifically at the parts of the atom. Well, we have protons, neutrons, and electrons. And so if we look at that, we understand that the valence electrons, if you remember from last 6 weeks, are the parts of the atom that are responsible for connecting together to form compounds. Okay, and number 4. The formula for glucose is C6H12O6. How many elements does glucose have? Well, let's write that down. C6H12O6. And it says how many elements does glucose have? Well, the answer is G. It has carbon, it has hydrogen, and it has oxygen. It did not ask the total number of atoms in this question. Number 5. Which of the following list all the elements that are present in a molecule of potassium carbonate? Well, we know we have K, we have C, and we have O. If we look at our periodic table, we're going to find out that K is going to be potassium, C is carbon, and O is oxygen. So C is our answer. It was just a matter of looking at the periodic table to see what was going on. Okay? All right, our next question, number 6. In the following chemical reaction, what symbol represents a single atom? Well, if we look at this, what symbol represents a single atom? Well, let's eliminate the ones that are here. Well, 2K means 2 potassium atoms, so that is wrong. Okay, there's 2 atoms there. H says H2 or K2O. That is incorrect also, because that's more than one type of atom. O2 is 2 oxygen atoms together, so that's wrong. Mn is manganese, so that is the right answer for letter F. Okay, number 7. In the equation above, what is the product? Well, the products are what's on the right side of the arrow. So if you notice, it's 2MgO, so C is our answer. Remember, the reactants are the things on the left side of the arrow. Number 8 says, new substances formed during a chemical reaction are indicated. So we got to look at this. New substances formed during a chemical reaction are indicated. Remember, the new substances are the products. So F says on the left side of the equation, but we know the products are not on the left side. We can immediately eliminate that. On the right side of the equation, and are called reactants. That's not true because the reactants are on the left side. Letter H, on the left side of the equation, and are called reactants. No, we're looking for products. Letter J says on the right side of the equation, and are called products. That is the correct answer for number 8. Number 9, 4SiO2. How do you determine the number of silicon atoms in the formula above? Well, it's 4SiO2. So we got to look and see what we do here. Well, Si has an invisible 1 right there. So what we have to do is take this, we got to take the coefficient 4 and multiply it towards the 1. So it's going to be 4 times 1 equals 4 silicon atoms. So let's see what fits that. So if we look at number 9, the answer is going to be this one right here, B. The silicon atoms equals the coefficient 4 times the subscript 1, which equals 4, just like we did above, okay? Number 10, which of the following is correct? This one shows the reactants in the right place and the products in the right place, but the arrow is wrong. The arrow is pointing to the left. Letter G just shows reactants and products with no arrow, so that's incorrect. Letter H shows reactants with an arrow pointing to the right to products, that is correct. And letter J has reactants with some sort of box pointing to the products, that is also incorrect. So letter H. Number 11. CH4 is an example of, let's see, we have chemical equation, chemical formula, chemical reaction, and chemical symbol. Well, it's not an equation because we don't have the yield sign and the products and the reactants showing up. It is a chemical formula for a compound of CH4. It is not a reaction, and it is not just a symbol. It's CH4, which is a chemical formula. Number 12 says, how is the arrow read in a chemical equation? You remember, it is like an equal sign in math, but we call it yields, so letter H. Number 13, which of the following contains the greatest number of elements? So the one that, if we count up the different atoms that make it up, it will be our answer. So if you notice, A just has S, so it only has 1. B has CH, so it has 2 different elements. C has Al and Cl, which is aluminum and chlorine. It only has 2. And then we have D, which is HNO3, or HNO2. So we have the H, the N, and the O. So it has 3 kinds of elements. So our answer is D. Number 14. Which of the following contains the greatest number of elements? Well, this is just like question 13. It was just repeated in the exam. So it's the same answer, okay? Number 15. Which of the following lists all the elements that are present in a molecule of potassium carbonate? So K2CO3. So it's K2CO3. So which of the following lists all the elements that are present? So we have carbon and oxygen. That's true, but it did not list the potassium. So that's not it. Phosphate and calcium? No. C, potassium, carbon, and oxygen? Yes. Letter D, phosphorus. Can't quite read that one from here, but it's definitely going to be C, potassium, carbon, and oxygen. Okay? Okay, next question, number 16. Acetate, acetic acid is a compound found in vinegar. The chemical formula for acetic acid is CH3COOH. So CH3C, let me repeat that. It's kind of hesitating on me. CH3OOH. So how many different elements are in acetic acid? Well, we have carbon, hydrogen. These are both oxygen, and that's also a hydrogen. So there's really only just a handful of elements that are there. So it says how many different elements are there in one molecule? So the answer will be F. Carbon, hydrogen, oxygen. Okay? This one doesn't count because it's already been mentioned over here. Okay? So the answer is 3. Now we see a phase diagram in this particular question. Now the phase diagram is just saying solids, liquids, and gases. So we're looking at how those things are working from each other. So the top one says phase 3, and then the second one below it says phase 2 and phase 1. So phase 1's here, phase 2 is here, phase 3 is here. This arrow going up right here says evaporation. So we're basically going from a gas, or from a from a solid to a gas. This one right here is just a cycle that's going through. So we have evaporation here, we have melting here, we have freezing here, and we have condensation right here. So remember, freezing is when it goes to a solid, melting is to a liquid, condensation is taking a gas back to a liquid, and then evaporation is taking a liquid to a gas. So it says, by studying the terms and directions of arrows in the diagram, you can determine that, and we're looking for the answer that's going to fit that, and the answer is C. Phase 1 is a solid, phase 2 is a liquid, and phase 3 is a gas. Okay? So we have the gas, we have the solid, we have the liquid. Okay? Number 18 says, Drew added yeast and sugar to lukewarm water and placed it in a flask. He stretched a balloon over the opening of the flask. After several minutes, he noticed small bubbles rising along the side of the flask as the balloon slowly began to inflate. Drew concluded that a physical change was occurring. Well, that's true, but it's more than a physical change. There's some chemistry problems going on in there to cause the gas to form. So it's more than just a physical change. The bubbles indicate a chemical change. That's true. Then finally, H, the water, sugar, and yeast were products of a chemical reaction. Actually, those, we are looking for a gas as a product. The gas isn't showing up there. Those are really the reactants in the situation. So G is our answer. And number 19, a student mixes two solutions planning to produce a chemical reaction. Which of the following is not evidence that a chemical reaction is happening? Color change, odor change, temperature change, no observable change. So color change is a chemical reaction in most cases. Not always though. Like if we make Kool-Aid, that's just simply the dye and or the food coloring changing the color of the water. Odor change after a reaction happens is definitely a sign of a reaction. Temperature changes always are reaction changes. No observable change, well that would be our answer. If there's no observable change, then no chemical change has occurred. Number 20, which of the following is the best evidence that rusting is a chemical property rather than a physical property? Rust forms slowly. Well, that's not always the indicator because some reactions do form slowly, some happen fast. Rust can form on any iron. Well, that may be true, but that's not the answer to the question. Remember, the question says, which of the following is the best evidence that a rusting is a chemical property? Rust cannot turn back into iron. That's one of our main deals about a chemical reaction is it's difficult to change back. Rust does not look the same as iron. Well, that may be true, but the best answer we have is H. Number 21. Which of the following is a chemical property of iron? Melted when heated, actually melting point, freezing point, boiling point, those are all physical properties, believe it or not. They're not chemical properties. Okay? The next one says sticking to a magnet. That is also a physical property. Rusting over time. That has to do with other elements coming in contact. That is a chemical property. Conducting electricity is also a physical property. So letter C is our answer. Okay, 22. Which of the following is a chemical property associated with wood? The ability to burn. We also have, and yes, burning is a chemical property, but let's look at the others. Snapping when bent. No, that's just a physical property. Floating on water. No, that's a buoyancy thing, whether or not something can float. It just means it's less dense than water. So that's not it. Having a rough surface, that's also a physical property. So burning will always be a chemical property. Number 23. The Best Friend Club uses invisible ink to write notes to one another. The invisible ink is actually lemon juice that is clear when it is put on the paper, but turns brown when a club member heats up the paper. Once it is heated, it never is invisible again. This is an example of a chemical change because it can't be changed back. Okay, 24. Which of the following demonstrates that a new substance can be formed from a chemical reaction? Okay, a new substance is what we're looking for. Milk souring. Well, milk souring, remember we learned about that. That is the bacteria in milk that causes lactic acid to be created in the milk. And so that is definitely a chemical reaction. But let's look at the other. Water evaporating, physical change is just simply a change from one state to another. Iron bending, that's just a physical change. Helium-filled balloon floating, that is also just a property of gas. So F is our answer. Okay, next set of questions. 25. Which of the following best describes a chemical reaction? A compound crushed into a fine powder? No, that's physical. Atoms break apart into even smaller pieces. Now, atoms breaking apart, that doesn't happen naturally. That's like, splitting an atom, that kind of atomic nuclear reaction stuff. No. Letter C says, existing electron bonds break and reattach to one another or other atoms. That is true. Molecules move faster until they fly apart from one another. No, that's just simply energy being added, like heating a substance up. So that's not it. Okay, 26. Which of the following is often the way that compounds are formed? Joining nuclei between atoms? No. The nuclei don't join. Changing matter into other states? That's a physical change. Sharing electrons between atoms? Yes. Changing elements to other elements? No, they don't change to other elements. A student places 0.5 grams of baking soda in a balloon and 25 milliliters of lemon juice in an Erlenmeyer flask. After stretching the opening of the balloon across the neck of the flask, the student raised it to dump the balloon soda into the flask. He immediately observed forming bubbles in the flask, and the balloon began to expand. The student concluded that A, the bubbles indicated a chemical change was occurring. It's forming a gas. Question 28 says, a student placed 0.5 grams of baking soda in a balloon and 25 milliliters of lemon juice. And that's a repeat question, so we already went over that a minute ago, so we'll ignore that one. Question 29, a student mixes two solutions, planning to produce a chemical reaction. Which of the following is not evidence that a chemical reaction is happening? I think this is a repeated question, but still, let's go ahead and go over it. A color change, B, an odor change, C, a temperature change, no observable change. That was our answer because all the others show a chemical reaction. Okay, next question. Question 30. Okay, so we have the same kind of diagram going on as an earlier question. We have phase 1, phase 2, and phase 3. Remember, this was a gas. The next one was a liquid. Oh, I think I got that backwards again. Solid at the bottom. Solid here. Liquid. And gas. That's phase 3. So all the arrows indicate physical changes. Okay, so we could just imagine water going into each one of those stages and it's still water. Okay, last question. This really goes in line with the lab we did earlier this 6 weeks. It says red cabbage contains a water-soluble pigment that can be useful as a tool in detecting the pH of a solution. So it shows the pH number as well as the color. So 2 is red, 4 is purple, 6 violet, 8 blue, 10 blue-green, and 12 greenish-yellow. Students collect the following data using red cabbage as an indicator pH for the different solutions. A is blue, B greenish-yellow, C is purple, D is red. Using the pH chart, which of the solutions tested by the students is most likely to have a very high pH? Okay, so we have to coordinate the color to the right thing. Solution A was blue, and so blue was an 8. Okay, solution B was a greenish yellow. So greenish yellow was a 12, it's the highest. Then we have solution C, and C was purple, and purple shows in our chart to be a 4. And then solution D is red, and red is a 2. So it said Using the pH chart, which of the following solutions best describes the most likely to have a very high pH? So we're looking at a high pH. So our answer on this one is going to be solution B, because it had a 12. Okay, if you have any questions about this test, see me in tutoring. Feel free to post a comment, and I'll comment.